Hello everyone, in this particular video we are going to solve the problem number 1.14 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. So a train of length L is equal to 350 meter starts moving rectilinearly with constant acceleration of W is equal to 3 into 10 to the power minus 2 meter per second square. Okay, so let us first draw the train. So this is the train of length of 350 meter and it starts at t is equal to 0. So initial velocity is equal to 0. So this is the initial velocity with a constant acceleration of w is equal to 3 into 10 to the power minus 2 meter per second square. This is the constant acceleration, and let us say this is the configuration at t is equal to 0, where the position of tail side is, let us say, given as x is equal to 0, and the front side is given as x is equal to 350 meter. Now after time t is equal to 30 seconds, the locomotive headlight is switched on, that is called the event 1. So let us draw the configuration at time t is equal to 30 seconds. After a time of 30 seconds, the train has moved by a certain distance. So let us say it has moved and then reached at this particular location. Then this is the configuration at t is equal to 30 seconds. It is saying that the front headlight is actually switched on, and this event is called the event 1. Now if we want to find what is the distance the train has traveled, that we can find from the equation of motion. We can write s is equal to ut plus half into wt square. Here w is acceleration and this will be 0 because the initial velocity is 0. Then s we can write half into 3 into 10 to the power minus 2 into 30 seconds whole square. Then if we solve this particular thing, we can get 13.5 meter. So basically the train has moved 13.5 meter of distance. So if initial position of the tail was x is equal to 0, then for the event 1 the position of the tail is x is equal to 13.5 meter, and position of the front end we can write it as x is equal to 350 plus 13.5 meter. So basically this is the position of x is equal to 363.5 meter. Now after that it is saying t is equal to 60 seconds after that event. After that event means event 1, the tail signal light is switched on, and that event is called the event 2. So let us say after 60 seconds of this particular event, that means total time of 60 plus 30 is equal to 90 seconds. So let us say at t is equal to 90 seconds, the train has moved some more distance, and let us say this has came at this particular location. Okay, and if we want to find the distance by which the train has moved, that we can find it as s is equal to ut plus half wt square. Then initial velocity is equal to 0, and we can write half into what is w, 3 into 10 to the power minus 2 into 90 whole square. Okay, if we solve this we can get 121.5 meter. So basically from t is equal to 0 to t is equal to 90 second, the train has moved by this particular distance. So we can clearly write the position of tail is x is equal to 121.5 and position of front end is x is equal to 121.5 plus 350. So we can get from here 470.5 meter. Now the question is asking that find the distance between these events in the reference frame fixed to the train and to the earth. So right now we are talking about the frame of reference which is fixed to the earth. So this is the frame of reference which is fixed to the ground or the earth. Okay, so with respect to this frame of reference, the event is taking place at this particular location, and this location, the position of this one is 363.5, and the event 2 is taking place because tail light is switched on. So event 2 is taking place at x is equal to 121.5. So basically it is asking what is the distance between these two particular events. So the distance we can write is equal to, let us say this is event x1 and this is x2. So distance we can write x1 minus x2. This is 363.5 minus 121.5 meter. So if we subtract this one, we will get 242 meter, or we can write 0.242 kilometer. Okay. Now the second part, it is asking that find the distance between these two in the frame of reference of the train. Okay, so in that case, frame of reference is inside the train. So let us say that this is the train and the reference is actually sitting inside. Okay, and then it is the position of this particular headlight when it is switched on. Let us say this particular distance is x, and the tail headlight when it is switched on, then the distance between these two is y. Okay, and whatever the velocity of the train, whatever the acceleration of the train, this x and y will be same for this frame of reference which is actually sitting inside the train. So in that case, what is the distance between these two events? The distance between these two events is x plus y, that is equals to 350 meter, which is the length of the train. Okay, now coming to the second problem. In the second problem, it is asking that our frame of reference is actually moving with constant velocity relative to earth. Then in that particular case, with respect to that reference frame, the two events is actually occurring at the same point. So in that case, what should be the velocity of that reference frame? Okay, so let us say that we are having the reference frame of this one, which is actually moving with a velocity of v, and then we are having the train it is starting. So the initial velocity u is equal to 0, and acceleration we know w is equal to 3 into 10 to the power minus 2 meter per second square, and this particular location we know x is equal to 0, and this particular location is x is equal to 350 meter, and this is the condition at t is equal to 0. And we have said that, let us say at t is equal to 30 seconds, the train has moved by certain distance, let us say by this distance it has moved. And then if we talk about with this frame of reference, then with respect to this, the train will have the velocity in this particular direction, in the initial velocity. Okay, so we can write from here that what is the distance it has traveled in 30 seconds. So we can write s is equal to ut plus half into wt square. What is u here? That is in the negative x direction, so we can write minus v into 30 plus half into what is w, 3 into 10 to the power minus 2 into 30 whole square. Okay, and this particular thing we know from the previous example, that was 13.5 minus 30v. So this is the s we got, that is the distance moved by train in 30 seconds. So this particular location we can write x is equal to 13.5 minus 30v, and this particular location we can write x is equal to 13.5 minus 30v plus 350, because the length of the train is 350 meter. Okay, and at this particular event 1, the front headlight is switched on. Okay, and then if we talk about what is happening at t is equal to 90 seconds, then at t is equal to 90 seconds this has moved by some more distance in that duration. So let us say the train has come to this particular location, and if we find the distance traveled by the train, that we can find out again from the equation of motion, ut plus half wt square. U is the initial velocity, which we know that velocity v in the reference frame of the particular k, and then we can write v into 90 plus half into what is w, 3 into 10 to the power minus 2 into time is 90 whole square. So this we have found out in the previous example, that we know this is 121.5 minus 90v. So this is the distance moved by the train in 90 seconds. Okay, so we can write what is the location of this one. The location of this one is 121.5 minus 90v. So we know that in this particular case that the location of the event 1 and this is event 2, the location of event 1 and event 2 both are same. So we will equate the position of the event 1 and the position of event 2. So what is the position of event 1? That is x is equal to 13.5 minus 30v plus 350, and that is equals to position of event 2 121.5 minus 90v. Okay, so we can get from here 60v is equal to 350 plus 13.5 minus 121.5. So this is nothing but minus 242. So from here we can get velocity is equal to 4.03 meter per second, which is approximately equals to 4 meter per second. Okay, so this is the velocity of frame of reference k, which is a constant, so that the first event and second event, that both will take place at the same time. I hope the entire procedure is clear. Thank you.